Hi friends, in the last video we have seen how an LCR circuit reacts when it is subjected to external alternating voltage, right? For the same case, we have found the IM, the current amplitude, to be Vm by Z. Z is the impedance. So I can write this as Vm by root of R square plus XC minus XL whole square. Now there is something called as resonance. Resonance is a condition or state where the current amplitude will be maximum. Observe this. Current amplitude is maximum, not the current. So what current amplitude is what? The maximum value of current possible in every cycle. So if this is my current, if my current varies like this is my IM, right? But if my current varies like this, say, then this will be my IM. So I am talking about the maximum value of IM possible. I mean the maximum value of that current which is maximum in each cycle. Don't get confused. That's why I'm repeating that again. Im is the current amplitude. So for what condition will the Im be maximum? Got it? When will it be maximum? When this term is 0, because denominator should be as small as possible and both are squares, right? So they can't be negative. The least possible is when xc is equal to xl. What happens? This term will be equal to 0 and hence I have my Im, that is the maximum value of Im possible, as Vm by R. This is something like a purely resistive circuit. Okay, so this is the condition for resonance. The condition is known as resonance. Okay, what is xc? I know that it is 1 by omega c. And what is xl? I know that it is omega l. So if my omega is equal to 1 by root LC, then I'll get resonance condition. And this frequency, this particular frequency denoted by omega naught, is known as resonant frequency, which is equal to 1 by root LC. Hope everything is clear till now. So at resonant frequency, that is which is equal to 1 by root LC, the current amplitude is maximum and hence it will be equal to Vm by R, where R is the pure resistance of the circuit. Okay, this resonance has many practical applications. I'd like to discuss one. You might have seen these metal detectors in airports or some public places like that. You have a doorway. When you pass through that, and if you carry any metal, it will give an alarm sound. Actually, this doorway is nothing but a coil of many turns, or you can say it is an inductor. And this is in turn connected to some capacitor and some circuitry. Okay, and this equipment or this circuit is set before in perfect resonance condition. Okay, so that the current amplitude is maximum there. And when you pass through a metal, when you pass through this doorway with a metal, what happens? This is an inductor, right? And when you carry a metal or when you place a metal inside an inductor, what happens? Its inductance increases, as we have discussed before, and hence the XL, the reactance of this inductor also increases, and hence you have this current which varies in the circuit. So if you carry a metal and pass through this doorway, the inductance of the coil increases and hence the net impedance of the circuit changes and current changes. And so you have some mechanism to detect the current change and give the alarm. This is how it works. Now, as omega varies, the Im also varies, right? So if I plot Im, the current amplitude, versus omega, I should get the maximum value at some resonant frequency omega naught, right? How will the graph be? It will be like this. The maximum value is achieved at omega naught. Okay. Now I need to define the sharpness of resonance, right? Sharpness is nothing but this one, how sharp the graph is. So if you have more sharpness of resonance, the graph would have been something like this, even more sharper. Of course, this is not a sharp curve, observe it. It is smooth only. And if the sharpness was less, it would have been something like this. So what is sharpness of resonance? It is the way to decide the quality of your circuit. I mean, if you have more sharpness of resonance, Your radio or TV can be tuned well, tuned accurately, exactly. Are you getting me? So we want the circuit to be sharp. We want the resonance to be sharp, and it is measured by a quantity known as quality factor. Let us define it. Before that, let's define something else. See, my Im will be maximum at omega naught. I have to find an omega where my Im will be 1 by root 2 times of the maximum possible Im. I mean, this is Im max, right? I want a omega where my Im will be 1 by root 2 times of this maximum possible value of Im. Now, why am I interested in this? Observe this. If my Im is this one, 1 by root 2 times of the maximum possible value of Im, then what will my power be there? I square R, right? So, Im max square R by 2. So, this power at that point will be half of this is what? This is the maximum possible power. So, I want such an omega where my power will be half of maximum possible power. Let it be somewhere here. This is Im max by root 2, say. Now, as you see from the graph, there are two values of omega which can give that. Are you getting me? Let this be omega 2 and this be omega 1. And by symmetry, you can say that the omega naught is the midpoint of these 2 points, omega 2 and omega 1. Now, the distance between these 2 points, that is omega 1 minus omega 2, is often referred to as bandwidth. You might have heard this term. And this is nothing but 2 the delta omega. Delta omega is the distance, this distance or this distance. Got it? So this is known as bandwidth. The sharpness of resonance is mathematically defined as omega naught by 2 delta omega. This is the sharpness of resonance. Of course, it is often called as quality factor Q also. Now, smaller the delta omega, sharper or narrower will be the curve, right? So sharper will be the resonance. Got it? Now, there are two values which give this half the power, right? Let's try to find them. Say omega 1 is the higher value, okay? Now, at omega 1, what happens? My Im will be Vm by root of r square plus omega L minus 1 by omega c square, right? This is by the formula which we derived in the last video. At omega 1, what I'll get? Im max by root 2 will be equal to this one, this Im. Of course, here I have to put omega 1. Okay. Now let us solve this equation in detail. Hope you understood it. My Im max by root 2 should be equal to this one, Vm by root of r square plus xc is 1 by omega c minus omega L whole square. Of course, here it is plus, I'm sorry. This is omega 1. Okay. Now, what can I write this as? I know what is Im max. That is Vm by R, right? That is something like a purely resistive circuit. It is Vm by R. I have root 2 here. I can write this as Vm by root of same R square plus omega L minus 1 by omega 1 C whole square. Now, let me write it again. We'll go slowly. Vm and Vm gets cancelled. Observe the denominators. R root 2 should be equal to root of this whole term, r square plus omega 1 L minus 1 by omega 1 C whole square. If I square on both sides, I'm going to get 2r square here, and that is equal to r square plus same xc minus xl whole square. So what did I get? R square is equal to omega 1 L minus 1 by omega 1 C whole square. It doesn't matter if it is xl minus xc or xc minus sl, because anyway I have square here, right? Now, putting this into simple terms, what can I write? My R should be equal to omega 1 L minus omega 1 C. Okay. You might as well say that 1 by omega 1 c minus omega 1 L can be written here now, the negative of this. It doesn't matter because anyways we have two values of omega 1 and omega 2, which satisfy our half power condition. So if you take the other way, you're going to get the other value of omega. It doesn't matter anyways. Let us solve for one value now. This r is equal to this one, right? And what can I write omega 1 as? Now I took the positive value here. So my omega 1 will be the higher value of these two. That is omega naught plus delta omega. The omega 2 will be omega naught minus delta omega, right? So here I'll substitute omega 1 as omega naught minus, no, omega naught plus delta omega. And here also I'll do the same thing, omega naught plus delta omega. And here I have C. Hope it's not getting complicated. Observe one thing. This one I'll write it as same L minus, I have something right, and I'll take omega naught common from this one. Here I had omega naught plus delta omega into C. Observe this. I am taking omega naught L common. That is omega naught common from this term. What will I get? 1 plus delta omega by omega naught. Now why am I taking omega naught common from these two terms? Because I want to get this term, delta omega by omega naught. In quality factor I had that term, so I'm interested in it. Here even I can write this one as 1 plus delta omega by omega naught. Observe one thing here. When delta omega by omega naught is very less, then you can approximate this term to be what? I can write the same equation as this one, 1 plus delta omega by omega naught. First term doesn't change. And here I can write 1 by 1 plus delta omega by omega naught as 1 minus delta omega by omega naught. Got me? Because when delta omega by omega naught is very less than 1, if it is very small, by binomial approximation, I can say that 1 by 1 plus delta omega by omega naught, this one. This can be written as simply 1 minus delta omega by omega naught. That is what I have done here. This term I wrote it as 1 minus delta omega by omega naught, and I have 1 by omega naught c here, right? It can be written as omega naught L because that is the resonant condition. Omega naught L should be equal to 1 by omega naught c. That's it, right? So let me write it again. L delta omega I have here minus L omega naught plus L delta omega. So finally this and this gets cancelled. I have 2L delta omega here, which is equal to R. Remember that. And let's write it again. We got what? R is equal to 2L delta omega. And what can I write? 2L delta omega is equal to R. So delta omega is R by 2L. And delta omega by omega naught will be R by 2L omega naught. So omega naught by delta omega, the reciprocal of this, will be 2L omega naught by R. Here I have 2 and here also I have 2. I mean I'm dividing the equation by 2. So I'll finally get this one as L omega naught by R. You know that this is the quality factor, right? So finally where did we end? We got the quality factor or the sharpness of resonance as L omega naught by R. And don't think inductor is special because quality factor is expressed in terms of L. This can as well expressed in terms of capacitance as 1 by omega naught CR because that is the resonance condition, right? Omega naught is what? Root of LC. So omega naught L is nothing but 1 by omega naught C. And hope you understood it. Keep watching. Bye.